Hello. 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 Hello.
Good evening, ma'am.
Hello.
Good evening, ma'am.
Good evening. Good evening. Very good evening. Right. Just we wait for 2 minutes, then we will start.
No problem, ma'am.
Okay. Oh, have you seen the topics what we discussed in yesterday's class?
Last week's
In
class.
last week class. Yeah, last week class.
Yeah, Java. It's how the versions changed. SE 11
Yeah,
in
yeah,
2012, SE 07 in 2014,
yeah.
18. Sorry. So like that,
Mm,
the versions changed. It is an object oriented, and
mm.
classes like parent and child class and parent class.
Yeah,
And from the class,
and also object.
human is a class, and objects are like man, woman, and
Yeah, child.
child. So that
Uh,
way.
uh,
So
mm,
the examples you have given. So
okay.
object oriented, we have web applications,
So,
applications of database.
yeah, some concepts of object-oriented programming, such as inheritance, polynomial,
Yes,
encapsulation.
encapsulation is like binding of coding and data together.
Yeah, yeah. Mm.
That I have run.
Abstraction, right?
Yes, instructions.
All these are the object-oriented programming concepts, and also we discussed about some characteristics, simple characteristics of the
Yeah,
Java
int, float,
programming.
and how main, then flower brackets, that
Mm, mm.
coding, like how it looks like
Okay, good.
structure, structure
Yeah,
of that
structure. Yeah.
coding.
Okay, okay. Okay, good. Right. Shall we start?
Yes, ma'am.
Yeah. Now, in our today's class, we are seeing the module 2 concepts. Here in this, we are going to see uh, what is JDK, what is JVM, and what is JRE, which are fundamental for executing a Java program. And also, we are going to see what are the various keywords that we can use in Java, and what are the various data types that we can use in Java. What is a variable, how it can be declared, and what about the type conversions and castings, that is data type conversions and castings, and also what are the various operators that we can use in Java, and how to write a fundamental basic Java program. So on all these things that we are going to see in this module 2. And I'm going to show the first Java program that you have in your syllabus also, lab program, that also I'm going to show. So first, before going to see a simple Java program, and before going to see the basic building blocks which are needed for writing a Java program, first we need to know about the environment of Java. So that's why first we are going to discuss about JVM, JRE, and JDK. So here, JVM stands for Java Virtual Machine, JRE stands for Java Runtime Environment, and JDK stands for Java Development Kit. Right. Now, first we are going to discuss about JVM, Java Virtual Machine. Now, here, JVM is the engine that drives the Java code. So, in most of the other programming languages, uh, such as C and all those things, compiler produces the code for a particular system. But in case of Java, the Java compiler produces a byte code for Java virtual machine. Now here, directly whatever the code produced by the compiler, that can be passed directly to the operating system of the particular system for the execution in case of C and C++, all those things. But here, the Java compiler produces a byte code, which is to be called as dot class file. Generally, when we execute a program, there we can see formation of dot class file, right? That dot class file itself is to be called as bytecode for Java. So this bytecode is passed to the Java virtual machine, right? And we know that Java is a platform independent one, but Java virtual machine and Java runtime environment are platform dependent. That is, they are having different configurations for different operating systems. So mainly, what are the tasks of Java virtual machine? It loads the code, it verifies the code, it executes the code, and it provides runtime environment for executing a particular Java program, right? Next, coming to here, we are saying that our compiler produces a bytecode for Java virtual machine. So what is that bytecode? So bytecode is nothing but it is a program code that has been compiled from source code to the low level code. So it is a very low level code machine. That is, it is present in zeros and ones. The bytecode is nothing but it is present in zeros and ones, which is to be called as low level program. So that bytecode is nothing but a Java compiled program which is present in high level language. That high level language is converted into low level bytecode, that is low level language. So which always be present in zeros and ones. Now that bytecode can't be understanding by any other components of our Java. Only the Java virtual machine can understand this bytecode, right? And this bytecode can be converted into the native machine code by the JVM. So here we are saying that the JVM is platform dependent. The JVM is platform dependent. So for Windows, the JVM is looking different for Windows 8 and for Windows 10 and for Windows 11, like that. For different operating systems, the JVM is different. And for Ubuntu, it is different. And for Unix, it is different, right? Now, whatever the machine code required for that particular operating system, the bytecode what is given to the JVM can be converted into the machine code, right? That machine code is passed to the operating system for execution, right? So initially, when we are writing a Java program, that will be available in a high level language. So that high level language program, when we compiled that one, that high level language program is converted into low level code, which is to be called as bytecode. This bytecode is understandable by the Java virtual machine, and this Java virtual machine converts the bytecode into native machine code, which can be given to the operating system for execution, right? And coming to the second component, which is Java runtime environment. This is an open source software distribution that has Java class libraries and specific tools and a separate JVM. And JRE and JDK, both are interrelated components, right? So if you want to run the bytecode on any platform by converting it into native machine code, you must need JRE, developer runtime environment is necessary, right? So JRE acts as a software layer on top of your operating system, which enables us to execute a Java program. And coming to Java development kit, it is a collection of classes: Java compiler, Java virtual machine, interpreter. So here the JDK is a collection of classes, compiler, and interpreter. We already said when we are talking about the characteristics of Java, we said that Java is an interpreted language, not it is simply compiled language. It is an interpreted language. So here Java is having interpreter, its own interpreter, right? Now it also consists of useful utilities for debugging, for documentation, for compiling and running the Java programs. Here you can see the utilities that are the components which are present in Java development kit. So first one is Java C, which is nothing but Java compiler, which converts the source code into bytecode. Now, how we can use this Java C means Java C file name dot Java. So here file name represents whatever the Java file, whatever the code we written, we save that code with some file name. That file name we write here. And Java, simply Java. Java is a Java interpreter, which executes the Java application byte directly from class file, right? Here the class file is created directly from class file. This Java executes, the Java interpreter executes the program. And here JDB, which is nothing but Java debugger. This allows to step through the program one by one, line by line, and set breakpoints and examine variables. Wherever the variables are present, wherever the errors are present, all these checkpoints can be placed by using this Java debugger. And a servlet runner, so which is used to run the servlet programs, so web server programs, what we write in Java, and applet viewer, which is used to run the applet programs, that is web-based programs. So these two are the programs, these two are the components that can be used to run the web-based applications. These are the normal Java applications, and these two are used for running the web-based applications, right? All these are the various components that are present in your Java development kit, right? So here you can see how hierarchically all these components are present. So here you can see this entirely is a JDK. So JDK contains inside of it JRE plus some development tools, right? And JRE within it contains JVM and some library classes, right? So here I represented the hierarchy. So here you can see Java programming. So we have the Java development kit. Here we have the .java file, that is whatever the program that we have written, that is to be called as .java file. Here we have the Java runtime environment. The compiler converts the .java file into bytecode, which can be represented with the .class file. So this .class file is not created by us. This .java file is created by us. This will be saved with some file name .java, and that Java file is converted into bytecode, that is .class file, by the Java compiler. This is not created by us. This is created by the Java compiler. Then this class file is given to the JVM, Java virtual machine, which it converts into native machine code. This machine code is given to the operating system for execution. Then our Java program can be executed in our particular system, right? This is the entire procedure. The same thing we summarized here. JDK used. JDK means Java Development Kit, which is used to develop and run a Java application. The required environment is Java Development Kit. JRE is just to run the Java application, and here it is nothing but Java runtime environment. JVM is nothing but it is responsible for actually executing our Java code. It executes our program line by line. So JVM is an interpreter. So Java is a both compiled and interpreted language. So whatever the diagram earlier we seen, the same diagram is represented in this way, right? So nothing more than that. And so we seen what the basic environment that we need for executing the Java programs. Next, we are going to see for writing Java programs, we need some Java tokens. What are those tokens that we want to know? Now, what is a token first? A token is the smallest element of a program that is meaningful to the compiler. So always a token means something. It explains something to the compiler, right? Now here, there are different tokens that we can use in Java. So those tokens are, some tokens are to be called as keywords. Some tokens are to be called as identifiers. Some tokens are to be called as constants. And some tokens are to be called as special symbols, and some tokens are to be called as operators. These are all different types of tokens that we can use in writing a Java program, right? Now, let us see about these tokens one by one. So first we are going to see keywords, right? So here, all these are the keywords. Keywords are nothing but predefined or reserved words in the Java programming. So what is meant by predefined or reserved words? Reserved word means those words are reserved for the representation of a particular thing in Java program. That word cannot be used for other purposes. It is reserved only for doing that particular work. Right. So that type of words are to be called as reserved words. So here you can see some of the reserved words I represented in this table. So here you can see abstract, which is used to make a class as an abstract class, or which is used to make a method as an abstract method, right? And in the same way, catch, the statement which can be used in the that is exception environment. So in order to throw the exceptions, we can use this catch and all those things. And here you can see Boolean, which is a data type. And here you can see break. Break is a control state variable, and byte, it is a Boolean data type. Right, and case, which can be used in the switch statement, like that. For int, for is the for looping statement. Go to is the jump statement. Interface, which is used to define an interface in our Java, right? And package, which is used to define a package. New, the keyword which is used to define the object, right? Import, which is used to import some libraries in predefined libraries in the Java, like that. So all these each and every keyword is having its own specific cause, right? So all these keywords cannot be used for other purposes. That is, I cannot use this as the name of a class, or I cannot use this as the name of a method, right? Like that. These cannot be used for other purposes. These are all the reserved words, right? So while we are writing the program, you can know everything, where we can use these keywords. Like that, you will know all those things, right? Now, next, the second type of tokens are identifiers. What are the identifiers? Identifiers are nothing but the general terminology or the naming of variables, functions, arrays, etc. Now, here you can see how I can name a variable, right? Here I can write a variable name as like this, my variable. I can write the variable name as x, or I can write the variable name as I. I can write the variable name as x1, right? So all these are the valid identifiers. That is, a variable name or a function name or an array name should starts with either a letter or underscore or dollar. Okay, and it doesn't have any spaces between two different words. I can use two different words for representing a variable. Here, my is one word, variable is another word. But here I didn't given any space, right? So that's why here it doesn't contains any other special symbols except underscore. Except underscore. Here it allows underscore. You can see here. I have written some underscore of underscore array. Like that I can write it. Except underscore, it doesn't allow another special symbol, right? And here I can use numbers also in the variable names or method names or array names, etc. Right. Now here you can see some example invalid identifiers. All these are the valid identifiers. You can see some invalid identifiers. Here I have given a space, so it became invalid. Here I started with 1, so it became invalid. Here I used plus symbol. It is a special symbol which cannot be accepted. And here I used another special symbol, which is hyphen, which cannot be accepted. Here I used ampersand. This also can't be accepted, right? All these are the different variable names which are invalid in our Java, right? So like this, any variable name or function name or array name can be represented by using these identifier. The name of anything can be represented by using identifier. But you have to remember one thing, no keyword can be used as an identifier. No keyword can be used as an identifier, right? Next, coming to constants and literals. What are the constants? Constants are nothing but normal variables, but only the difference is their value can't be changed. The constant value can't be changed. That is, it is having a fixed value. The constants can also be called as literals, right? And they may belongs to any data type. Constant may belongs to any data type. So here you can see final data type variable name. So here, why I written here like this is, suppose if I write final. So if here I have no correct pointer for writing this. Now I am writing final int. So here this is data type and my variable name is, let us say, A, right? Now here you can see final is a keyword which makes the integer data a as a constant value. That is, whatever the value I given to a, suppose if I given 10 to a, this value can't be changed throughout of the program. So this keyword makes this variable as a constant. You can learn more about this final keyword in our further classes, right? Now here, just a constant means a variable whose value can't be changed, right? Those are also to be called as literals. Right. Next, coming to the special symbols, what the various special symbols that we use. And these special symbols are having their own meaning. And the special symbols can't be used for other purposes as well instead of their meaning, right? Now here you can see brackets, square brackets. These are used for the representation of array. Array subscripts can be represented by using brackets, right? So such as I can represent a single dimensional array like this. I can represent a single dimensional array A as like this, right? And parentheses. Parentheses can be used to represent functions, right? Suppose, for example, here I am writing a method or a function named as sum. How I can write the method? Like this, I can write the method. And brasses. Brasses are used to represent the starting and ending of the block. That is, for example, so here I want to write a class, let us say yes, and whatever the things that I want to write within the class should be represented within a block. For the representation of that block, we use these braces. And comma, which is used to separate more than one statement. And semicolon, sometimes it is used for initialization lists. Right, if I want to initialize any list, I can use this semicolon. Asterisk, which is used to create a pointer variable. Assignment operator, which is used to assign the values. Generally, the assignment operator is equal, right? So all these are the special symbols that we can use in Java, right? Next, coming to the operators. So we can use different types of operators, and these operators are classified based on the function that they can perform. Now here you can see some of those operators, list of some of those operators, such as arithmetic operators, unary operators, assignment operators, relational operators, logical operators, ternary operators, bitwise operators, and shift operators. So you can learn more about these operators, what the various arithmetic operators are present, what the various unary operators are present, what the various assignment operators are present. So all these things, the explanation about all these operators can be seen at the end of this session, right? Now, we will explain clearly about each and every type of operators, right? Now, with this, we completed the tokens. So whatever the tokens that we need for writing a Java program, that are keywords, variables, constants, operators, special symbols, etc., tokens, etc. Right? All these are the tokens. Next, coming to variable. Now, how to declare a variable, how to initialize a variable, right? Now, what is a variable first? So, a variable in Java is a data container. That is, that saves the data values during Java program execution, right? Every variable is assigned a data type that designates the type of the data that can be stored in that variable. So a variable is a memory location name for the data, right? So here you can see this is my RAM, that is random access memory. Whenever I want to execute a program, so the input data can be accessed from the RAM only, and the program will also be stored in the RAM only. The instructions can be taken and executed, right? Now here in the RAM, there is a reserved space when we declared a variable, right? That reserved space stores the value that is given to that particular variable, right? So any variable, suppose if I want to use an integer variable, or if I want to use a real value, or if I want to use a string, or if I want to use a character, anything before using that should be declared first in Java, right? Now, how to do the declaration? Here is the declaration syntax for variables, right? Here you can see data type, variable name, right? If you want to represent more number of variables with the same data type, you can write all of them in a same line by separating with commas. So here you can see data type, variable name 1, variable name 2, variable name 3, so on, variable name n. That is, all these n variables are of this data type, right? So here you can see example, sum. This is I want to represent it as an integer variable. Now here you can see int sum. Now I want to represent some more variables of integers in the same line. So here you can see int sum, a, total, average underscore marks, which is terminated by the semicolon. Definitely you should terminate the statement with the semicolon, right? Now here all these 4 variables are of integer type. Now float b, here b is a real value, char c, c is of character, right? So this is a way of declaration of variables in Java, right? Now initialization of variables. How the variables can be initialized? There are mainly 2 ways to initialize the Java. One is compile time initialization and second one is runtime initialization. Now, runtime initialization contains different methods such as constructor-based dynamic initialization, setter methods, which are used for dynamic initialization, and we can use some built-in methods to initialize the variables dynamically, and dynamic initialization using expressions, and we can use command line arguments, as well as we can use a scanner class. All these are the various ways of initialization of variables in runtime, which is to be called as dynamic initialization, right? And here compile time initialization, which is to be called as static initialization. Here we will explain about this compile time initialization. Later, while we are writing different programs, you can experience all these different types of dynamic initializations, right? Now, we are seeing compile time initialization. Now, at the time of declaration of a variable, if we assign a value to that variable, that is to be called as compile time initialization. So here you can see that data type, variable name is equal to value. So here I am writing data type as int, variable name as sum is equal to value is 40. That is, sum is an integer type of variable which stores a value 40, right? In the same way, multiple variables of same type can be initialized within a single statement, right? Here you can see int time is equal to 10, speed is equal to 20, right? And char, var, this is a variable name. Here the character, it contains a character h, right? Like this, we can initialize the variables in compile time. But while we are writing the programs, you can see, you can experience the remaining dynamic initializations all, right? Now, next, here you can see what are the different types of variables that we have. So we have mainly 3 types of variables: local variable, static variable, instance variable. What is meant by local variable? A variable which is declared within a method is to be called as a local variable. And a variable which is declared within a class, that is to be called as instance variable. And a variable which is declared with a static keyword, that is to be called as a static variable. That is, suppose for example, so here I have a class named yes. Here I have a class named yes. Now in this class, I'm going to declare some variable which is to be called as an integer variable. Let us say int yes. Let us say some other value I will take int x, right? This is an instance variable which is present in a class, right? And I'm going to write another variable as static, right? Now static, here I am writing it as int static int y. Now This is to be called as a static variable. That is, here we used the keyword static. Now, I'm going to write a method m within this class. Now, this method contains a variable named as int z, let us say. Now, z is to be called as local variable. So here you can see the three types of variable. This is to be called as instance variable, which is present in a class. This is to be called as static variable, which is declared with a static keyword. And this is to be called as that what we have, right? And next, you can see next one, data types. So in while we are discussing about variable declaration, there we are using a data type, right? Now there we see int data type, right? Now other than int,
Hello, ma'am. Your system is hanged. I'm unable to hear.
hello Padmavati, is it audible?
Yes, ma'am. Now.
Okay, right. Now, primitive data types are of basic data types, and non-primitive data types are of derived data types. Now, here you can see Boolean and
Ma'am,
numeric.
previous slide only I can hear half.
Here,
After it is.
this one only. Types
Yes.
of variables, this one.
Yes.
Have you heard this one?
Up to static, I was able.
Okay. Now, what is a local variable means? The variable which is present within a method, right? A static variable means a variable which can be declared using the keyword static, right? And instance variable means the variable which is present in a class. That is, suppose for example, here I am writing a class, right? Now, here how I can write a class and name of the class I can write. Let us say name of the class is yes. Now here I'm declaring a variable named x, which is of integer type, right? This variable is to be called as instance variable, which is present in a class, right? And here if I am writing this before this variable a keyword static, which becomes a static variable. So if I write the keyword static before this int x, this becomes the static variable, right? Which is defined with a static keyword, right? And a local variable. What is local variable? So my class S is having a method named S. Within this method, I declared another variable called y. Let us say it is y, right? This variable is to be called as local variable. These are the three different types of variables that we have, right? Now, next coming to the data types. So here we seen that when we are writing the variable, every variable is declared by using a data type. So now till now we seen integer data type. So like that, what the different types of data types that we have, right? Now here you can see what are the different data types that we have, right? Now we have basically two data types, primitive and non-primitive. Primitive data types are the basic data types. Non-primitive data types are the derived data types. So here you can see the primitive data types can be divided into again Boolean and numeric. Now Boolean data type is used to represent the Boolean values. Boolean values are nothing but 0 and 1, or otherwise they can be represented as true or false, like that. And coming to numeric, they are divided again into two types, characters and integrals. Now coming to characters, it is having a data type called char, which is used to represent the characters, right? And single characters we can be represented by using char. And coming to integral values, we can have integer and floating point values. And integers can be represented by using 4 data types. Those 4 data types are byte, short, int, and long. And floating point values, that is real values, can be represented by using 2 data types, which are nothing but float and double. Right. Now you can see these data types and clearly. Now here you can see primitive data types, which are the built-in data types, or standard data types, or basic data types. Now coming to integers, we have 4 built-in data types. Those are byte, short, int, long. And for floating points, we have 2 data types, float and double. And for data types, which is nothing but Boolean. And coming to non-primitive data types, these includes coming to non-primitive. Coming to non-primitive data types, these includes various classes, interfaces, and arrays, right? Now, doesn't supports any unsigned types, and every data type is having a default value, and a Boolean is having a default value false. So all primitive data types in Java are portable. That is, they are platform independent. Now you can see the sizes of different data types. So how much of data that they can be stored. Here you can see byte means 1 byte. 1 byte means 8 bits of data. Right. Now it can store the numbers from -128 to 127, and the default value is 0. Right. And short means whose size is 2 bytes, which can store the values which ranges from -32,768 to 32,767. And here its default value is also 0. And integer means 4
That
bytes.
is -32, 768 is what, ma'am?
This is the value, integer value. Integer value.
Okay.
From this integer value, and that means we can represent these values in binary. They can be stored in binary only in the memory, right?
Okay.
Right.
Okay.
This -32,768 binary value to 32,767 binary value, those can be stored in this short, right? And int, which takes 4 bytes of space. So now from this value to this value we can store. And long, which takes 8 bytes. So here this is byte is 1 byte. 1 byte means 8 bits. Here this is 2 bytes, that is 16 bits. Here it is 4 bytes. So how many bits are there here? 4 8s are 32 bits, right? And here it is having 8 bits. It is of 8 8s, 64 bits.
64.
Yeah, 64 bits it's take. And floating real values, float and double both. And float stores 4 bytes of data, whereas double stores 8 bytes of data, right? And coming to Boolean, 1 bit of data can be used. That is, it stores either 0 or 1. So, right, true or false. Generally, we will represent 0 with false, 1 with true. And a character, which can store 2 bytes of data, right? And here you can see.
Why Boolean only represented in bit, all others in bytes?
Yeah, since all others can also be represented in bits, but we converted them into bytes. We written like bytes. So here, in case of byte is equal to 1 byte, I can write here it in 8 bits.
Okay.
In this place, I can write 8 bits. In this place, I can write 16 bits. Just for our convenience, we are writing them in bytes. Right? 1 byte is equal to 8 bits, but it cannot store byte value. Boolean cannot store byte value. It stores only 1 bit data. 1 bit value is there for Boolean. It stores either 0 or 1. That's why we represented that as bit. Right?
Okay. Yeah.
Right. So these are all the default values that what we have in these data types, right? And coming to the basic structure of Java program, how we will write a Java program, how it can be executed, right? Now here you can see every Java program should be written within a class. Every Java program should be written within a class. So here you can see that class example. So here class is a keyword that what we use for the representation of a class, and example is name of the class, right? Now your program starts with the class name. Java program by default starts with the class name, right? And whatever the things that I want to write within the class, those can be represented as a block, that is within open bracket and closed bracket. In this block I need to write. Now I represented a method within this class. That method here I have written is main method, right? Now in Java, how we write main method is, this is only the way to write the main method. That is public static void main. Within the parenthesis, we will write string args. This is the standard representation for writing the main method. I'll explain all these details later. So why we write public, why we write static, why we write void, so why we write these string args, all these things I'll explain, right? And within this method, here I have written a print statement. Generally in Java, the print statement can be represented as like this: system.out.print. I can use or system.out.println. Ln represents the new line. If I want to print that particular statement in a new line, I can use ln, right? Otherwise, I can use simply system.out.print, right? Print is a predefined method in Java, which is presenting system.outstream. System is a class, predefined class. Within this class, this print method is present. So that's why we need to access that print method or println method in Java like this only, system.out.println, right? This is the structure of, basic structure of Java program, right? And here you can see how to compile and run a Java program. So first we need to save the Java program with the class name in which my main method is present. Generally, our program may contain number of classes, but my main method can be represented in one class. Now, with the name of main method class name, we have to store the program. That is, this program can be saved as example.java. We need to give an extension .java for that file, right? And here, for the compilation, I can use this command, javac, that is Java compiler, example.java, that is file name.java, javac file name.java, right? And for executing the program, I need to use this command. Java is the interpreter which executes the Java program. So Java space example, that is the class file which is created by this command can be used here, not the direct Java file. Here it uses the class file. No need of mentioning dot class here, since it obviously knows, since that was created by the JVM itself, right? The JVM itself creates the class file. So that's why it knows that one. But here we are creating the file. That's why we need to give the extension. .java extension we need to give. But here no need of giving the extension .class, right? So this is for compilation of the program and this is for running the program, right? This is a basic structure of Java program. So every Java program should be written within a class. Any Java program may contain number of classes and it should definitely contain a main method. General Java application definitely contains a main method, and the basic or standard representation for main method is public static void main string args, right?
We have used only flower brackets where we are
Yeah.
mentioning that the class of the file. We did
Yeah.
not use other parentheses or any other.
Here for class opening and for class closing, we need to represent these two parentheses, which represents one block. And for method opening and method closing, we need to represent a set of parentheses, which represents this method, ending of the method and starting of the method. So definitely we should represent these parentheses in a Java program. It is must.
And
Right.
semicolon is also a must.
What that?
Semicolon you have given after hello. Right?
Yeah, it is must. It is a syntax. It is as part of syntax only we are representing semicolon.
After string you have mentioned the square brackets. Is the
Here,
compulsory?
yeah, compulsory, because this args is an array of type string. This args is a command line argument which is passed to the main method. It is an array of type string. That way we need to definitely write string, and we need to write args, and this bracket is also must and should, but this bracket can be represented here or it can be represented here as well. I can represent here also that bracket, right? Args is the name of the argument, right? This args is an array of type string, right? Do you understand? Yeah, right. Next, now we are going to write a simple Java program, what the knowledge that we learned till now. Now we want to read two values and print the values. Now here you can see class. Every program starts with class. So I represented class, example 1. Here ex1 is my class name. Now here I want to write the main method. Here I am writing a simple Java program. I'm not going to write much classes in my program. Just I want to write only one class and I want to write only one main method. Now public static void main is my main method. Now here I declared a variable named first, which is of integer type, int first. Here at the compile time itself, I initialized that variable with 10. And here I represented another variable second, which is initialized with 20. Now here I did some operation addition. So now int sum is equal to this first plus second. That is, I want to add these two values, right? Now I want to print these two values. For printing these two values, I use system.out.println. So here plus we written in the print statement, we written plus, right? This plus operator is to be called as concatenation operation, not the addition here, right? Here it is the addition this operator can be used in two purposes in case of Java. One purpose is between the numerical or real values to add the values. And in the strings, it can be used for concatenation, that is combining, right? Now, here plus first, here this is a concatenation operation. Plus is here again, it is a just we are representing a character. Plus this is a concatenation second, plus here this is a concatenation as well, and is equal to this is a character plus some value, whatever the sum value we are getting here, that sum value I want to write, right? So now this is my simple Java program, right? So now if you don't want to complicate this program, just simply you can print sum like this. So here you can see, you don't want to do all these complications. Just sum can be printed like this, right? Now this is a simple Java program. And here you can see one more thing. Here, what this represents is, we said that dynamic initialization is there. That is compile time initialization, that is using command line arguments, right? That type of representation is there. Now, in case of these command line arguments, when we are executing the program, while the time of execution, we will give the values. Those values are stored into this variable, right? This is an array which contains this type of structure, Array contains this type of structure. Under the same name, we can store different values, right? And each value can be represented by using an index value. Those index values can be represented like this, right? Now, whatever the first value we given, that first value will be stored here. Whatever the second value we will give, that second value will be stored here. And args of 0, which can be used to access this first value, args of 1, which can be used to access this second value. Those two values I am printing here, right? This is one way of initialization. This is other way of
What
initialization.
will be the print output for in this example 2?
Example 2, in case of example 2, while we are, how this can be compiled, so how it can be stored first?
No, output, how it will show in the after print.
I'll tell you. I'll tell you. First, let me know. So how this can be stored first? Let me
Yes.
know.
Okay.
This can be stored as ex2.java, right? This can be stored as ex2.java. Is it or not? Yeah.
Yes.
Now, how to compile this one? I will use a command called java c space ex2.java, right? This is a what the command that we use for compilation. After that, I need to run the code, right? Now, for running, what the code I will use? Java, right? Now, at this time, I need to write just class file name, right? Now, what is the class file name? ex2 space. Here, when I want to use command line arguments, I need to give the values here. Suppose here I given the values 15 space 56, right? Now, what becomes the output when I run this program is, it prints first 15 and then it prints 56 then, right? That is, the first value I given 15 is stored in arguments of 0. The second value I given 56, which is stored in arguments of one position, index 0. In index 0, 15 will be stored. In index 1, 56 will be stored. Right. Now, arguments of 0, which stores 15, that value is printed. Argument 1, which stores 56, that value is printed here. And when coming to this program, how it can be executed? How it can be executed? Now, let me know.
Java file main ex1.
ex1. Here I can write ex1.java. Now, here ex1.java. Now,
output is
here no need of giving these values. Here no need of giving these values, because here I'm not taking any value from command line. Correct. Directly compile time initialization is there, but here I am using compile time initialization.
Because arguments, it is arguments.
Yeah, we used control command line arguments. That's why at the runtime I need to give the values, right? Here compile time I am giving the values, right?
We have given command of adding both two, so it will directly give the answer 30.
What that?
Because we have given the sum is equal to formula, first one plus second.
Yeah.
So it is directly giving out.
Yeah, it directly gives the output. So here directly, no need of writing this statement also, right? Here directly I can write first plus second. That also, this also prints the same value, right? And if I want to add these two, now here I want to add these two. How I can add these two means?
Into sum.
No problem. No need of writing sum as well, right? Directly I can add. Now here I can write simply.
R1 plus R.
Yeah, I can write args of 0 plus args of 1. Now here I can write like this. Here it adds these two values, and what becomes the output? 15 plus 56 means it becomes
71.
71, right? Like this, the output will be present. First 15 will be printed, then 56 will be printed, then the addition of these two values, 71 will be printed, right? Do you understand?
Yes.
Okay, right. Next,
But
primitive.
if we have to practice, shall we download Java or something, ma'am?
Yeah, definitely. You need to
So-
download Java, or you can use directly NetBeans, or some online compilers will be there. You can use online compilers, right? Anything can be used. Online compilers are available for executing the Java programs. No need of installing Java in your system. You can directly execute the program online. Whatever the program you want to write, you can write and you can execute. Right?
Means in notebook only we have to write,
Right? What?
where we have to type
If
all
you
this
want to execute your Java program in your native system, you need to install Java and you need to write a program in a notepad, and that should be saved with .java, right?
okay.
And if you want to execute the program in online compiler, it always provides its own notebook space.
Okay.
In that space, you can write the program. Simply, I'll show some online compiler to you. Okay?
Okay.
Okay, right. Next, we are going to see operators in Java. We already listed out these operators earlier. Now we are discussing about these operators. So first we are seeing arithmetic operators. These are all the arithmetic operators that what we can use in Java. Addition, subtraction, multiplication, division, modulo division. So here division only is having two answers. One is quotient and other is remainder. For the representation of quotient, we will use this operator. For the representation of remainder, we will use this operation. Remaining all are, addition, subtraction, multiplication are generally what we use. But for multiplication, we will use asterisk symbol, not just simple cross, asterisk symbol, right? Now here, this is a simple Java program which represents all these arithmetic operators. So here I have taken three variables, A, B, C, which are of integer types. Now here I compile time initialized A with 10, B with 2, and C is equal to, here I am doing addition. I want to print addition result. And here C is equal to, I implemented subtraction. Now subtraction result I printed. Like that I did multiplication, division, as well as modulo division, right? So all these operations can be performed and it prints the outputs of those things. These are all the arithmetic operators. And coming to unary operators means that can be operated on a single operand. If you see, all these operations can be operated on double operands. Definitely, we should have two operands, A and B. So if A and B both are not there, which can be added to which value? So I cannot add, right? Addition cannot be performed with unary. Subtraction cannot be performed with unary. So we need to have two operands, definitely, in case of these. But here, all these are unary operators. With a single operand, I can perform. So first one is unary minus, not operator, increment, decrement, bitwise, complement. So here, unary minus, which is used to convert a positive value to negative value. Just A is there. If I want to convert that A into minus value, I can use minus before that A, which becomes a negative value. Now, not operator, true, if I want to convert true to false or false to true, I can use this not operator. I have the Boolean values, right? True or false. True, if I want to convert true into false, I can use not. Or if I want to convert false into true, I can use not. Right, increment operator. This works on an integer. That increment operator can be represented in two ways. One is post increment and another one is pre-increment. Post increment operator can be represented like this, num plus plus. The operand can be represented after the operand. Operator, this is the operator. This is the operand. Operator is represented after the operand. That is to be called as post increment. And if the operator is represented before the operand, this is to be called as pre-increment. Right? What is the meaning of this one is post increment means first we will assign the operand operand value, then we will increment the operand value. Pre-increment is first we increment the operand value, then we will assign that value, right? In the same way, decrement also, post decrement and pre-decrement. And here one's complement, right? Here this tilde symbol, which is to be called as tilde, this symbol is used for the representation of complementation. Complement means the same thing. 0 is converted into 1 and 1 is converted into 0, right? Bitwise, that is here. What is the difference between this not and tilde means not can be applied on a 1-bit data, that is 0 or 1 or true or false. But tilde can be applied on more bits. That is, if I have 1 0 1 1, if I apply tilde operation on that 1 0 1 1, it can be converted into 0 1 0 0. Like that, more number of bits can also be converted. Right. These are to be called as unary operators. Now, coming to assignment operator, just simply equal can be used as an assignment operator, but some shorthand assignment operators are also there. Here you can see this is the simple assignment operator, and here you can see shorthand assignment operators. When I want to add a value B to A and result if I want to store in A, that can be represented as A plus equal to B, which indicates that A is equal to A plus B. So here we can write like this, A plus equal to B, which equivalent to A equal to A plus B. In the same way, for all arithmetic operators, I can write A minus equal to B, A into equal to B, which is equal to A is equal to A into B. Like that it represents, right? All these are the shorthand assignment operators. Next, coming to relational operators. So we have all these 6 types of relational operators: equal, not equal, greater than, less than, greater than or equal, less than or equal. So generally, single equal is used as assignment operator. Double equal is used equal. This is the comparison. Double equal is the comparison. Single equal is the assignment. Here you can see this is the assignment. This is the assignment, but this is the comparison. Here we are comparing A and B, whether these two are equal or not, that we are comparing, right? Now, in the same way, whether they are not equal or not, whether they are greater than or not, less than or not, greater than or equal to or not, less than or equal to or not, all these are used for comparisons, right? And next, logical operators. So we have mainly 3 logical operators: logical and, logical or, logical not. Right. Now, logical and, you may all know that and operation truth tables also. So if I perform and between these two, I'll get 0 only. If I perform and between these two, I'll get 0 only. If I perform and between these two also, I'll get 0 only. If I perform and between these two, I'll get 1. And operation, logical and operation. And logical OR, coming to OR, if I perform OR between 0, 0, I can get 0. If I perform OR between 0, 1, I can get 1. If I perform OR between 1, 0, I can get 1. If I perform OR between 1, 1, I can get 1 only. Right, logical not. Just simply 0, if I represented not of 0, which becomes 1. If I represent not of 1, it becomes 0. Right, the same what we explained in the unary operators. Right, now here all these are the logical operators what we have. Right, and coming to the next one, ternary operator. Ternary operator is the conditional operator. Ternary operator is the conditional operator. So here is the syntax for writing the ternary operator. Variable is equal to expression 1 question mark, expression 2 colon, expression 3. Now first it checks this expression. If this expression is true, then this becomes the answer. That is, this value is assigned to variable. Now, if this is false, this becomes correct answer. This value is assigned to variable. Like this it works. Now, here you can see N1 is equal to 5, N2 is equal to 10. So here I used that ternary operator. N1 max is equal to N1 greater than N2 question mark, N1 colon N2. Now, whether this condition is true or false, 5 greater than 10. Is it true? No, this is false. Since if it is true, this becomes the answer. Max becomes N1. If it is false, this becomes answer. N2 becomes max value. So 10 is the max value. Here we will get 10 as the answer. So this is the syntax for using this ternary operator, which is also to be called as conditional operator, right? Bitwise operators. These are all bitwise operators. Bitwise or, bitwise and, bitwise exclusive or, bitwise complement tilde, which we seen already in the unary operators, right? Now, logical and logical OR works on entire data, and bitwise operators works on bit by bit. That is only the different, right? Same thing will happen remaining, right? And shift operators, we can have left shift, right shift, unsigned right shift also we can have. Left shift is represented with 2 less than symbols. Right shift is represented with 2 greater than symbols. Unsigned right shift is represented with 3 greater than symbols. Unsigned right shift means it will not consider the sign of the operand that what we are using. That is, if I have minus a, that minus will not be considered. Only a can be shifted, right? This is to be called as unsigned right shift operator, and unsigned left shift operator is also there, but it is not supported by Java, right? And here you can see shift operators. Suppose if I write x left shift 4, now here you can see this is shifted towards left, like that it will be shifted, right? And here you can see examples for right shift as well, right? And unsigned shift also you can see here, right? So all these are the examples. And one more operator is instance of operator. So which represents, so what is the instance of that particular class? What is the instance of this class? Here, this is the instance of that class. Instance is nothing but, what is instance? Instance is nothing but its object, class object. So here we have an object S for this class. That instance is represented. So here we are saying that S instance of simple 1. Yeah, is it yes or no? Yes, it is correct. So it prints true, right? To test whether the object is an instance of that particular class or interface or not. This particular object is class of this one or not. That can be verified by the instance of operator, right? So all these are the different operators that what we have. And coming to type conversions, there we have 2 types of type conversions: implicit type conversion and explicit type conversion. Type conversion means converting one data type into another data type. So now here you can see implicit type conversion allows all these conversions. That is, which is also to be called as widening, right? All lower data types can be converted into their higher data types. That is, byte can be converted to short, int, long, float, double. Short can be converted to int, long, float, double, but short cannot be converted to byte. Short is higher data type, byte is lower data type. So short cannot be directly converted or implicitly converted to byte. Implicit conversion means the Java can automatically convert. This is an automatic typecasting, right? Char can be converted to int, long, float, double. Int can be converted to long, float, double, but int cannot be converted to short and byte. In the same way, long can be converted to float, double. Float can be converted to double, but double can't be converted to float, or can't be converted to long, or can't be converted to int, right? So these are all automatic type conversions, which are to be called as implicit type conversion. Explicit type conversion means forcibly if I want to convert, that is to be called as explicit type conversion, right? Now here, this that is to be called as narrowing. That is, we are converting higher data type into lower data type. That is to be called as explicit type conversion. So here you can see double value. I have a double value. Now, if I want to convert this double value into long, it cannot be automatically done. So that's why here I am using long before this D, I need to represent to which lower data type I want to convert. That lower data type should be represented within the brackets before that operand. So this is to be called as explicit conversion. Explicit conversion, that is forcible conversion. So here it will not be done automatically, right? So with this we completed type conversions, right? This is your first Java lab program. Here your lab program, which represents different operators. Here I represented arithmetic operators, relational operators, logical operators, and bitwise operators. Within the same program, I represented different operators. You can run this program in the Java compiler itself, right? Now, I want to show you one online compiler, right? So you asked me where I need to execute the Java programs. I'll show you one online compiler.
Yes.
Here you can see, if you, here I will share you one minute, wait. So see here, is it visible my screen?
Yes, ma'am.
Yeah, here you can see, I typed just Java online compiler, right? Now
Okay.
it displayed various online compiler which are available, right? Now
So
here,
any one of compiler I can go and whatever the
yeah,
exercise you have given program
yeah,
that
you
I
can
can type
execute.
and I'll get the output.
Execute. Yeah. Now here I am showing just program is I am taking. This is an online compiler for this program is, right?
Okay.
Now here there is already written a small program, class hello world main method. This main method prints the this statement, right? Now just I am going to replace this statement with some other text. Such as like this BCA online class. Now you can, I typed the statement, right? Now I want to run. Just here you can see run button, right?
Yes. Yes.
No need of saving anything. Automatically it will be saved. Just you can click on run. Just here you can see BCA online class, right?
Okay. Ma'am,
Right.
in examination point of view, when I have to run the program, I have to run on the compiler or how is it? Only write the
I
code?
think, do you have any practical exams?
No, but just to learn myself.
You can use online compiler, or otherwise you can install your own environment in your system and you
Okay.
can use it. Now here you can see one more execution, right? Just I given two variables A and B whose values are 10 and 20. I want to print their sum. Just I run the program. Now what you get?
30 is the answer.
30 is the answer, right? Now I'll show you something. Right. Now I will execute. See here. Oh, some error is there. I'll look at once. So here is not plus. Here I need to write the plus. Yeah, here you can see.
Yes.
Here it was taken A and B as two strings.
Individual numbers.
Two
Yes.
strings. That's why it printed as 10, 20, right? Now I will represent like this. Now you can see.
Yeah.
30, right? You need to write brackets here for adding these two. It is not considering now them as strings, right? Like this, you can execute any program. You can write on your own and you can execute.
Sure.
Okay. So I hope that you understand the concepts, what we discussed in today's class.
Thanks a lot.
Prepare, just try to write some basic programs, right?
Yes.
You can refer w3schools.com.
Okay.
There you can have a number of basic Java programs, basic questions for writing Java programs. You can practice all those basic questions, right?
W3?
Schools,
W3?
w3schools.com.
Okay.
Okay?
Yes.
Okay, okay. Shall
Thank you, ma'am.
Okay, thank you. Shall I close? Shall I
Thanks
close?
a lot. Yes, ma'am.
I'm
Thanks
going
a
to
lot.
wind up the session. Okay, thank
Yeah.
you. Bye.
Thank you.
Bye.
Thank you. Bye bye.